Hello everyone, my name is Twice Robert. I'm looking at transitioning IP version 4 to IP version 6. I'm making that presentation. Now we want to look at a case where you're running IP version 4 addressing on your network, and then you want to transition it to IP version 6. The transition from IP version 4 to IP version 6 does not require an upgrade on all nodes at the same time. Ideally, IP version 4 and IP version 6 can coexist for some time. There are a wide range of techniques that are available during that time of transition from IP version 4 to IP version 6, and those categories, those transition techniques are categorized into three broad categories. The first is called dual stack technique, second tunneling technique, and third translation technique. Dual stack technique. With dual stack, the hosts and network devices run both IP version 4 and IP version 6 at the same time. This technique is useful as a temporary transition, but it adds overhead and sometimes uses many resources. The interface is dual stack and it forwards both IP version 4 and IP version 6 traffic. The drawback of dual stacking include the additional resources that are required to keep the dual routing table, routing protocol topology tables, etc. Then the other drawback is the higher administrative overhead. Troubleshooting and monitoring becomes more complex. So we have an example there looking at two routers connected together over fast Ethernet interface. The fast Ethernet interface of R1 is dual stacked. It is configured with an IP version 4 and an IP version 6 address. But also notice that for each protocol, the addresses on R1 and R2 are on the same network. So running a show IP interface FA00, the output confirms that first FA0/0 interface is operational and uses the IP version 4 address. Show IPV6 interface of FA00, again that output confirms that the FA0/0 interface is operational and also uses the IP version 6 address. The second, so that's all we can talk about dual stacking. The summary of it is that the interface, the nodes or the routing devices run both IP version 4 and IP version 6 addresses at the same time. The second technique is tunneling technique. The tunneling technique, isolated IP version 6 networks are connected over an IP version 4 infrastructure using tunnels. Now, in this case, the edge devices are the only ones that are dual stacked. So the other nodes may not need to be, will not need to be dual stacked. Scalability may be an issue if many tunnels need to be created. Tunnels can either be manual or automatically configured, depending on the scale that is required and the administrative overhead that can be tolerated. So for IP version 6 tunneling, for IP version 6 tunneling is an integration method in which an IP version 6 packet is encapsulated within IP version 4. So this enables the connection of IP version 6 islands without the need to convert the intermediary network to IP version 4. The intermediary network, in this case, being an IP version 4 network. So there's an example there, and it looks at the tunnel between sites. In this example, IP version 4 functions as a transport protocol. In this case, the protocol over which the tunnel is created. So the tunnel will be created over the IP version 4 network. IP version 6 is a passenger protocol, the protocol encapsulated in the tunnel and carried through the tunnel. GRE is used to create the tunnel and is known as the tunneling protocol. The third and last method of transitioning IP version 4 to IP version 6 is translation technique. Now, with translation technique, it uses a method called NAT-PT. NAT, Network Address Translation, Protocol Translation, where NAT-PT is an extension of NAT techniques, and it provides protocol translation services for legacy equipment that cannot be upgraded to IP version 6 and for some deployment scenarios. A router converts IP version 6 packets into IP version 4 packets and vice versa, allowing IP version 6 only devices to communicate with IP version 4 only devices. So again, here scalability may be an issue because of the resources that are required on the translator device. Now, as a comparison with dual stack and tunneling technique, dual stack and tunneling techniques manage the interconnection of IP version 6 domains. So there's an example there for NAT-PT. There's a NAT-PT example. You can notice that node A is an IP version 6 only node that wants to send an IP version 6 datagram to node D, and therefore forwards the packet to a NAT-PT router. The NAT-PT router maintains a pool of globally routable IP version 4 addresses that are assigned to IP version 6 nodes dynamically as sessions are initiated. The advantage of NAT-PT is that there are no modifications that are required on the hosts. So the translation takes place on the NAT-PT router for this case. So NAT-PT can be configured either dynamically or statically. So there is static NAT-PT and dynamic NAT-PT. That presentation summarizes the transition techniques that are used to transition IP version 4 to IP version 6. Thank you for listening.